Hello and welcome to my lecture on technical maturity. My name is Stein Espen Bø, working for SINTEF, and I will now go through the presentation in technical maturity. So this will be the content of my presentation. The first 3 points will give you some introduction. This contains the evaluation and award procedure, the introduction to the technical maturity and the requirements from Innovation Fund, and I will also share a little bit how to start. The next points 4 to 9 gives you more details about the feasibility study. So what is the feasibility study? How is this assessed, this technical assessment? How to scale it up? We need to describe the expected output of the project. We also need to describe the risks. This is really important, the technical and the operational risk, and what kind of documentation is needed together with the feasibility study. In the end, the point 10 until 13 will give you some hints, details and advices on things that is important. For instance, why do applications fail? So this is important learnings from previous applications. Also, how to prepare yourself for the application. I will give some good practice and advices for lessons learned and some final advice. The technical maturity will be only one part of the total evaluation of the Innovation Fund application. As you can see, there are several criteria that all needs to be addressed in your Innovation Fund application. And within all of these criteria, there is a set of topics to be covered. In this presentation, I will of course cover then the technical maturity. It is important that the maturity of your project is on a high level TRL scale. If you're familiar with the term TRL, I will address that a little bit later as well. It's important that your project has a technology readiness level between 7 to 9. That means it's fairly well developed, basically already a pilot test or going commercial. It's possible in some documents I've seen to also include TRL level 6. So in order to make this an innovation project, it needs to be innovative, but at the same time mature. So this means you need to do more than just incremental innovations. It must be innovative, so some really good innovations must be shown. For instance, scaling up, taking use new type of technology, and first of its kind projects are typical innovative projects. And further in the qualification of your project, it's important to see that the evaluation of the project will be done as a cascade. So you need to comply with each of these steps before you are allowed to the next level, and you can be discarded by any of these steps. So first of all, your project needs to be eligible and also admissible. The type of the project, and also from which member state you're from, which includes all of EU plus the European Economic Area, Norway, Liechtenstein and Iceland. It's important to have a certain degree of innovation, so it must be innovative. This will kind of tends to lean towards lower TRLs. Next, it's important that the greenhouse gas emission avoidance will be met. So you need to demonstrate a certain level of greenhouse gas avoidance. And at the same time, you need to demonstrate that your project is technically mature. And this is kind of pushing your technology readiness level, the TRL, upwards to the higher end of the TRL scale. Next, it's important that your project is cost efficient. It's kind of a bidding process. Most bang for the buck, or the most greenhouse gas savings per money. But it's important to be realistic here. If you're promising too high greenhouse gas savings and or too low cost for achieving this, you might have a winning grant, but in the end you will have a losing project. So it's better to be realistic, so that project can really be executed in a good way when it's granted. All your elements of the Innovation Fund application will be assessed and given a score. So each of the elements will be given a score. It's important to collect points throughout the entire application, and you have a maximum score here, as you can see, for each individual section of your application, and you also have a minimum threshold that you at least need to pass and overcome in order to be eligible for the fundings. When it comes to the technical maturity, as you can see, the minimum score is 3 points. So at least you need to overcome the quality of the technical maturity and receive 3 points here. But of course, after the series of Masterclass, I assume you will all climb for the top score on all of these criterias. If you have already attended more of the 2DPLOY's masterclasses, you will probably already have learned that the financial maturity is the area where most of the applications fails. However, the technical maturity is very important, and it's the second most frequent reason of failure, as you can see from this slide, which might be surprising to engineers and technical personnel. They normally find the technical part and the technology the most interesting. But it's really important to say that the feasibility study is much more than the pure technical technology part of the project. For instance, the risks and the mitigations especially are really important. You need to address the risks and how you will combat those risks. So I will give some examples of that later. So please pay attention to this important topic as well. So let's move over to some of the requirements in the technical maturity part. As you can see, it's important to try to switch your mindset rather from, instead of selling or trying to make an application for a grant, you should really try to sell your project to like investor group or the board. You need to provide really good confidence, and you need to make the receiver of your proposal, they need to believe in your idea, why this is a good idea, and how this will benefit them. It's important to to describe your readiness level in details, be very concise, be realistic, provide facts and figures so it's easy to understand what kind of technology you are providing. Further, it's important that you include all the relevant risks. You identify the risks and also explain in detail how you want to mitigate those risks. So you have good and clear strategies to avoid those risks from happening. Any supporting documents that can provide confidence, like a due diligence report, procurement quotes, memorandum of understanding, signed letter of intents and supports, feasibility study, etc. All kind of documents that supports your technology and the risks and the risk mitigation actions is really important to include here. Basically, you need to have all those documents in place, and really important is that you're telling the same story throughout the entire application. So quite often it's a teamwork to provide the full application, and of course different team members tends to address different parts slightly differently, but please be sure that you have a red thread throughout the entire application, and that all your story is consistent and all your documents are consistent, so it's easy to understand and no room for misunderstandings on your technology readiness, and all the other provided documents as well must be consistent with this. Coming back to the TRL levels, the technology readiness levels, it's important that your project is a technically mature project, at the same time innovative. So that means your project should have a TRL scale, a score between 7 to 9, as you can see here in the green box. I've seen also in a few presentations earlier that TRL 6 has been included. The most important thing here, I would say, is that you need to have as minimum at least pilot. You have demonstrated the technology in some controlled environment. You need to demonstrate that you have tested this, you have no showstoppers identified, or at least if you see some problems, barriers or showstoppers, that these are addressed and solved, because you need to make sure that you have a working system that can be scaled up without significant problems. So it's all about scaling up from a prototype in a controlled environment, or a prototype or a pilot in a working operational environment, all the way up to a full-scale unit, which is then used and tested in the real environment, and where you can also demonstrate the full performance of this technology. You can, of course, use arguments like it's the first of its kind, and it's state of the art that needs to be documented. If you can then by this project demonstrate that it's still improvements, still really innovative level of your project, for instance, that the production cost will significantly drop, reliability, the lifetime of the plant, the maintenance costs, there is reduced limitations, etc. This can be also good arguments. So even though you're in a high level TRL, you should still work to improve those points to make sure that your project is a very good, realistic, and successful project. So it's really, really important to make a very good and thorough job in assessing your TRL level of your project. Please do not overpromise your TRL level, and you need to prove and document why you argue for this TRL. So if you can show that the technology has been proven in pilots, and that it's documented by engineering principles or some reports, this is always good to connect with your application. If you see that your TRL might be a bit low, please make a good plan how to lift your TRL, work on those challenges, so you can ensure that in the future your TRL will be on the correct level. And it's better to wait until next year and apply when you have a project within the required TRL level, rather than submitting too early. So please make sure that you have a TRL within the level 7 to 9 before you send your application. it all boils down to the reviewer, the investor. They really want to make sure that your technology is working and that it can deliver the expected output in the end. When you're describing the output of your project, this is highly linked to your TRL level. So you need to demonstrate that you can really achieve what you have promised. As a part of the technical maturity section, it is mandatory to include a feasibility study. You will find a template available in the documents from CINEA or from the EU portal. However, it's not mandatory to use the exact template, but it's really important that all the questions and all the topics of the templates must be covered and answered. In total, the feasibility study can be maximum 60 pages, so it's limited to the number of pages. Of course, you can do a feasibility study internally in your company, but it's really recommended unless you have very good experience in building feasibility study on your own, that you use some professional engineering company at least to provide assistance. This will also lead to higher credibility normally. It's also a mandatory section to include a business plan. This is also limited to 60 pages. Such a business plan will demonstrate the value of your project. It might be supported by some additional reports like a due diligence report or third-party review or support. So these are all important supporting documents, and make sure that at least the feasibility study, which is mandatory, is included in your application. So under the project maturity section, the technology maturity, the financial maturity, and the operational maturity are each sections under the total project maturity. We will now dig deeper into the technical maturity part, especially looking into the feasibility study. The other parts, the financial maturity and the operational maturity, will be covered in other masterclass lectures. So where do we really start finding the documents and starting to make this feasibility study? There are several ways. Of course, one way is to start searching for the European Funding and Tender portal. Then you should search for the Innovation Fund and open the call. If you are preparing between any open calls, you can open the previous call to prepare yourself and find documents. But of course, when you are going to apply, you need to apply to an open call, and please use the templates and documents for the active and open call in your application. So this is the portal. You need to then filter for the innovation fund part, making sure that you are finding the calls related to innovation fund. Then you click here for to open the call. You need to scroll down and click on the conditions and documents. You will find them here in the menu on the left hand side, and then you need to expand and show more in the end. So by clicking here, you will then open the list of sections and documents, and if you zoom into the bottom part area of the list in the portal, you will then see here some supporting documents that will provide tremendous help in your application. Finally, you will find a feasibility study here, so you can download the document and you can prepare this as a separate document. And please remember that this is a mandatory document to the application. In this presentation, I will of course only address the technical maturity. The financial and operational parts will be discussed in another masterclass lecture. The description of the technical maturity from the evaluator side is this. As mentioned already, you can achieve 5 points in total. It's important then to address the technical feasibility itself, so demonstrating that the technology actually works. You need to describe the expected outputs, so the reader really understands what this project will provide. You need to explain the technology, how it works. It's important that it's understandable, this technology, so it can be understood and proven later that this works. What is really important is that all the risks you see with your projects are well described. Please include also technology risks, commercial risks, etc. in this section. And you need also to work on how to minimize those risks by your risk mitigation actions, addressing all your major risks, and providing evidence that okay, you understand the risk, you handle the risk, and therefore your project is in very good hands. Finally, it's important then that your project has a good quality. It must be a sound project. It must be a reliable project. So all the information that you provide must support. So now we will dig into the feasibility study, and I will guide you through the details of the template. The feasibility study template consists of a lot of elements. As you remember, it's not mandatory to use the template from the portal, but it's highly recommended to use it, since this will then cover all the topics needed to be addressed. Of course, you may use another template as long as you cover all these points. The template contains all these elements, as you can see here. And of course, the first thing you need to do is to define your project with some name, a title of the project, and a very good description of the project. It's important that the reviewer of this feasibility study very easy and early understands the concept of your technology, what you're trying to achieve, and you need to provide confidence that this technology will work according to your description. Of course, you can supply with supporting documents to prove and make better probability evidence that your technology will work. It's also very important to make sure that your technology is realistic. The feasibility study will be a fundamental document in the application, and a lot of other sections in the application will have reference to the feasibility study. So please make sure that everything is consistent with the feasibility study throughout the entire application. As you can see, there is a lot of details that should be described and addressed in the feasibility study, starting with the details of the location, describe the site, the location, logistic, stakeholders, etc. Also explain external factors like regulatory requirements, and make sure that all the needed permits are under control. If you have them already, that's very good to explain that. If some permits are pending, you also need to address that and make sure that or make it likely that all these will be granted in the end. It's all about making sure to the reader that there are no showstoppers, no concerns related to the location. I've seen in some previous projects myself that items that seems like a very small problem today might turn out to be major showstoppers later. So please try not to hide any small bumps or problems. but rather dig into them, solve them, make sure they are addressed and cannot hinder you in the future, as far as you are able to and aware of today. It's also important in your description to be very concise, use language that are easy for the reader to follow. If you have something to say it clearly, and when you are done saying it, then you're done. Rather than spending too many words without meaning, it's better to be very clear and honest and frank about what you're going to explain. It's important that you have ownership to the technology, so that is not a showstopper for you later. The technology is actually your legal rights to use. All the regulatory governmental permits are given, or at least you have very good processes on them. I think also the license to operate, the more soft side of it, the public acceptance, for instance, is really important. I've seen projects where the project in the end fails due to lack of confident or public acceptance by citizens. So it's important to also keep this in mind. Make sure that you have the goodwill from your local community and the people and everyone in your surroundings supporting your project as far as possible. And if there are any doubts, make sure you have good plans, good communication, etc. to mitigate on these things. Make sure that you describe your objectives, the goals of your project with the smart technology. The smart way of doing it is being very specific, have the goals defined in a specific, measurable, achievable, relevant and time-bound way. That makes it very clear, easy to verify and to check that your objectives have been met. You can of course make one main objective and then divide it into sub-objectives if needed. You should also make sure that you describe your resources. Make sure that you have control of the market, the supply of materials, that the vendors can provide you the correct quality, the correct volume, logistic chains are in place. So these are very important things. I've seen projects nearly becoming a showstopper. For instance, we had a project where one of the vendor had a really good quality. The product was approved. but then it turns out that that production capacity was only to some percent of our total need. So that led us to a phase where we really needed to redevelop and change our technology, which turns into a massive cost and a time delay. So make sure that you fully understand your value chains, your resources. Do you have the correct people? Do you have the clients? Do you have offtake agreements? Are the market willing to pay, etc.? So all these details are really important also in the feasibility study, since they will in the end turn the technical project as success or not. So going further into the technical assessment part, in the technical assessment, it is then very important to onboard the reviewer, provide a very clear picture of your technology. So all the supporting descriptions, giving more details about your process. Try to describe where are the technology today, how can this project develop it further, to which level or capacity or quality, etc. can your project bring this technology. What is currently the state of the art, and how will this particular project change the state of the art? If you are in a scaling up situation, this project of yours is really going to scale up the production significantly from previous technologies or previous existing plants. It's important to describe all those risks and mitigations, so all these are addressed in a good way. One way of doing this could be having backup plans. Sometimes it's not only solving a certain challenge, but maybe you need to avoid that challenge by going another direction. So if you have some alternative options, it's also so it could be smart to include these alternatives. So then you have like your main option is option A, but you also have an option B in case of failure of the first option. To really describe and give confidence in your technology, if you have engineering documents, design philosophy documents, basis of design, process flow diagrams, some calculations of capacities, layout, plot plans for the plant. These are all good to for the reviewer to really understand how this will look like, and also to better understand the technology. It provides confidence that you have actually studied the details, and it's likely that the technology will keep its promises. So a little bit more of supporting documents that you may include in your application. Process flow diagrams should be very easy to follow. It gives a very good overview and details of the technology. And if you can support those with real numbers from a pilot or from a previous study, if you can support with your layout and design P&IDs, for instance, showing that you have a good plan of how to construct your process. All these supporting documents will provide better understanding and more level of confidence for your project. If you have mass balance, energy balance diagrams, this also provides really good trust in your project and that the outcome will be as promised. Integration and scalability and the surroundings of your project is really important. Even though you have a greenfield project, there will always be some kind of tie-ins. For instance, road access, water, power, etc. But if your project is really integrated with some existing process, this is a really important field to have full control of all the various tie-ins, the signals, system boundaries, interference, dependencies with existing plant and your new plant. When it comes to upscaling, you will also face some kind of barriers normally. Make sure that it's possible to increase size. Sometimes it's not. You cannot always just build something bigger. Sometimes you need to rather keep the same size but multiply the number of units, maybe due to some physical limitations or other things. So you need to have good control of your upscaling philosophy, both on what you want to achieve, but also what is physical, practical, economical, beneficial in such upscaling. In all of these projects, it's also very important that you have control of lead times, various barriers. Is there any unforeseen problems? For instance, the globalization we see these days with wars, trade wars, protectionism, value chains are changing. This can cause significant problems, time delays, cost increase, etc. in your project. And it's important that you have a plan, have checked, have good mitigations, alternatives in such cases. I've seen projects where lead times, for instance, have been significantly changed during the execution of a project, and that leads to either significant cost increase, change in design, or delays in the projects. So to avoid problems like this, it's important to have a good plan early, check and double check and make sure that you have good plans for all of these integration and scalability and the surrounding of your project. And when it comes to the expected output of your project, then it's important to clearly explain all these kind of outcomes from your project. What is the quality of your end project? What is the availability, for instance, reliability of your plant or your process? Does it really require a lot of maintenance? The maintenance cost, will it lead to downtime or any other dependencies? So if you can support your project with experience from a pilot, that will give trust in an upscaled version. If you have process simulations that can demonstrate the outcomes of your process, like the quality, the volumes, efficiency, etc. I think it's important to have a good philosophy of your design. Is it optimized with respect to material flow for the operators? Is it easy to maintain the plant? Of course, not everything can be described in a project where maybe you're still in some upscaling. Not everything has been tested, but then you have a lot of assumptions. Make sure that your assumptions are realistic. Do some reality check on them. Are they plausible? If you have vendors or others that can verify your figures, your calculations, third-party engineering, etc., that also would bring more trust and confidence to your project. It's better to have more eyes and more assessments on your projects than your sole explanation from yourself. It's always good to make some assessment of your promised outcomes. So the technical performance assessment should be done. I think it's important to have some calculations on your assumed efficiency, energy consumptions, production volumes, the safety, reliability, etc. of your project. You need to describe the expected performance of your system or prototype while scaling it up. Can you compare it, your new project, with the existing technology that exists currently in the market, and explain how this improves, scales up, or makes something new. I think these are important topics, but it's also important to not promise too much. Do not exaggerate your project, especially during starting up some new technology or scaling up the size of the project. You will face challenges during your project. We often refer to them as some child disease. The first year or two in production, you might see a lot of minor problems, and you need to solve them one by one. So the first years, you're not likely to have the full performance of your plant. But as the years goes by, you will solve and optimize more and more of those small problems during the experience of developing your plant. If you see already in the application phase prior to the construction phase that you should have something more tested, simulated, or some investigations that should have been done, I think it's very good to be frank and honest about those. This shows really that you understand there is a risk, and you have a good plan to prove or solve those risk elements. If you also see upsides, I mean, could the performance even be further developed beyond the promised outcome from your project? If you have at least some hypothesis, or you see some opportunities for further improvement, that can also be described here. The techno-economical analysis is, of course, very highly linked to the financial maturity and the markets and value chains of your project. Here it's important to make sure that your capex estimates includes enough. Make sure it includes the pre-engineering, that you have contingency, that you have room for things that you see during your project. Most projects have unknowns and also unknown unknowns. So to allow for contingency in your capex is really important, but of course you need to make a balance with the correct contingency level that you plan to do. Your operational expenditures, the OPEX, may have several sensitivities. For instance, the value of raw materials can change over the project period. Power costs, logistic costs, labor costs, etc. Financial, the currency can change. The value of a euro today is not the same as a euro next year or the year after. So please also include escalation of currency over the time. Remember to also include the costs for waste, side streams, emissions, permits, audits, etc. There might be costs showing up later that you did not foresee as a part of your project, but quite often there are elements that will show up that you probably did not think too deeply about. It's really important that all of this is very consistent with the rest of your application. Must be consistent with your business plan, the technical assessment, the expected outcomes, the greenhouse gas avoidance, etc. So all of these parts need to be telling the same story. When it comes to the technical and operational risk, this is a section that is really important. Most failures in applications we've seen so far linked to the technical maturity fails on the risk and the mitigation part. The template has a format both for the technical risk and the mitigations there, and operational risks and mitigations. It's important to distinguish between the purely technical risks and the operational risks. You need to do a very thorough job on the risk register. I will recommend to keep your risk register a live document. Bring it up every month at least during the application writing, and keep it updated also after the submission of your proposal. And of course, if you get the grant and will start executing the project, you definitely need to look into your risks, keep them updated, see if there are any new risks occurring, use experts to solve the risks, because the risk register is a very good tool to avoid small items becoming large obstacles or showstoppers in the future. So the more you can be aware of risks upfront, plan mitigations to avoid them, the better situated you are for executing your project. It's mandatory to visualize your risks in a heat map, and I will soon show you one example of doing this. I strongly recommend to start early in preparing your risk matrix or risk register. It's definitely a benefit to keep this a live document. I also recommend to use a separate tool, a spreadsheet, or some digital tool to track your risks and your mitigations. The feasibility study provides these templates. If you use the template from the feasibility study, you can import your risks and mitigations from your live system, but it might be easier to keep it updated if you have that risk register in a separate tool. This is one example of a separate tool where everything is built in a spreadsheet. You have clearly defined impacts and clearly defined probabilities for each defined risk. So if you define a certain risk, then you can check the impact on each category, from personal injury to environmental issues, financial issues, or reputation issues. You can also define the probability, how often will this happen, and by combining those two numbers as a product, you will identify them in the heat map or the risk matrix as seen on the right hand side. You need to define then what are acceptable risks, unacceptable risks, or more evaluation required. The suggestion here is one typical way of doing this with red, yellow, and green columns. And then you can combine both the technical and operational risks in this risk register, and you can also include all the different impacts in the same register. By adding mitigations in the same spreadsheet, then you can also demonstrate for each individual risk how the total risk will be reduced. In some cases, you reduces the consequence or the impact of an event. In other mitigations, you reduce the probability for something to happen. So be very clear about are you actually reducing the consequence or the probability, and you will see that very easily in a risk matrix like this. You can also track the change of risks, the risk without mitigations and the risk with mitigations. You can track them, for instance, like arrows like this, showing that you have dealt with the most important risks, and they have now been shifted towards less severe risks. So this is a very good way of visualizing your actions and how you have worked with your risks and taken down your risk elements. When I held this presentation last year, I received a question about how can you make sure that changes in market conditions, for instance, how do you address those between application writing or submission until the project implementation? This is a really tricky question. There is no very simple answer to this. It's all about trying to predict the future. But at least there are some tools. Of course, you should allow for some uncertainty and make sure that you have some contingency or margins in your project. But I will also like to mention a method that I've been using. I'm not an expert in the method, but I've used it quite frequently together with some guidance. So this Danish professor, Sten Lichtenberg, he formulated a statistical tool back in the 70s to how to address uncertainties of projects in very early phases. And he called this method the triple guessing method, and it's based on wisdom of the crowd and some statistic tools. So very simply explained, if you collect a team of experienced people, they should at least have experience in the topic that you are trying to address. So if they are technical personnel or project developers or something, but you need to collect a team together that can assess your project and the risks, like the question here. What you will do then is ask every individual person in the room or around the table 3 questions. What is the true value will definitely not be below a certain minimum value, so it's at least less than 1% chance it's below this value. So take a guess on this value. Then you ask the opposite question. the true value will definitely not exceed a certain maximum, so it's less than a percent probability that it will exceed this maximum. And then you're asked to give your best guess. What do you believe is the true value? So each person individually answers these three questions, and from this you can then calculate an expected value. If you then take the minimum of the minimum column, so the person that has the lowest value, and then you take the average of the best guesses, and you take the max of the maximum column, combine them in this formula, you will have a very good representation of the expected value, and this happens to be very close to the truth in a lot of cases. I've previously been employed in a company, a large constructing company in Norway. We use this method in all our projects, in all our bids, and this really changed the earnings in this company. So we have a lot more trust in our projects, and we adjusted our bids based on risks. Sometimes we increase the costs, or sometimes we reduce the cost based on these risks and the expected outcomes. So this is a very powerful tool to address uncertainties, as long as you have experienced personnel understanding the problem, but they don't know the answer. But the wisdom of the crowd combined with these statistic tools will give a very good representation of the most likely outcome. So what kind of supporting documents do you need? I've already touched some of them, but it's very good to have as much supporting documents that can guide us as proofs of the technology and the expected outcomes. If you have simulations, third-party reports, independent statements, R&D results, etc. This will be very good to prove your expected outcome and demonstrating the technology. In addition, HACCPs, risk assessments, permits that is given, all these builds trust in your project. It shows that you have thought about a lot of potential risks, and also that you have the license to operate. If the technology is in compliance with standards, legislations, best practice, etc., these are also good evidence that your technology will work, and that you have a good plan how to make sure that the promised outcome will happen. So the documents, this is a list of some type of documents that could be provided. All kind of basic engineering documents will provide a good confident, especially if you have used engineering company, third-party companies to develop your project, then you will probably have good understanding already. You will have a design basis describing how the design of the project should be. All the basic criteria is there. If you have pipe and instrument diagrams, single line diagrams for electrical systems, heat flow or process flow diagrams for the process, both theoretical heat flow diagrams, but if they are calibrated or supported by for instance from a pilot case or from some experiments, then you have even more confidence in those numbers. A good description of the concept, drawings, plot plans, 3D drawings, balance of plant should be an important document. List of tie-ins, auxiliaries needed for the process to go as planned. If you have any external feed studies, HACCP or HACCPs, if you already have operational and maintenance philosophy documents, this will lead to a number of man in your plant, downtime, maintenance, access to spare parts, etc. will typically be mentioned in these kind of documents. All kind of permits, emission permits, labor permits, construction permits, electrical permits, etc. Are important. If you can describe your technology towards the best available technology, or if you have used the best available technology, the BAT, that is also important to include. If you have a project progress plan or project execution plan, the more levels of detail the better, but at least a master plan for the execution of your project will be very good and create a good confidence in your project. So from the call document, you can see that the feasibility study, which we have already addressed and discussed, is a mandatory attachment. You can use the template in the proposal, but you can also create your own, as long as this is answering the same questions as the template. It's important that the feasibility study is, of course, readable, accessible, in a good format, so it's printable. It must be within the limitation of 60 pages. The proposal in total is limited to 70 pages of Part B. And then you can add all these supporting documents, as we have already discussed. Also the contract documents, vendors, due diligence, all the other documents that will support your project, both on economical side, but also the technical side of the project. You must also ensure trust in that you have the best competence available to execute your project. Not only that you have the competence, but also the capacity. So not the best people, but also enough people, and also the experience of those people is important, because to execute such large projects really demands competence, capacity, and experience. Of course, you can support these with your own in-house personnel, include their CVs, but you can also add on third-party CVs if needed, to ensure that you have a good crew and that you will provide a successful project in the end. This is just one example of how a pipe and instrument diagram looks like. So this is connecting all the pipes, all the signals, all the valves, and how they control and regulate each other. By showing these kind of diagrams, it shows that you have prepared your project well, you understand the process, and you have actually studied the details of it. Further, if you then have a simulation or a process flow diagram showing the values in each step of your process, like this process flow diagram shows both pressure and temperatures and enthalpies throughout a process plant. If you have only theoretical or simulated values, it's better than nothing. If you can support them by real data, calibrated data from a pilot or from a similar plant, etc., that would also provide even more details to your project, and giving increased credibility and trust in this project. Further, if you have layout drawings, plot plans, 3D drawings, etc., this also shows your detail level of the planning, especially if you have tie-ins to existing plans. It's important to make sure that the tie-ins are possible, you have sufficient space, there's room for the new pipe, etc. And a master plan, maybe level 1, 2, or 3, including a Gantt diagram, would be very useful to understand how your project will be executed. If you have any proof of your expected outcomes of the project, like a performance test, a guarantee from vendor, some simulations, etc., that will also provide tremendous credibility on your project and will demonstrate that it's really likely that you will succeed with the promised outcome. So combining all of these, this demonstrates that you are really on a good maturity level on the technology. You have a good plan. It demonstrates that your organization is ready to execute a project like this. So finally, I will then explain a little bit on why do some of the applications fail on the technical maturity side. And as previously explained, technical maturity is the second most frequent reason for failure on Innovation Fund call applications. And if we dive into the background on this, we see that the technical risks and the mitigations are the most frequent failure. It's not sufficiently clear, all the details. The technology is not sufficiently supported by evidence. So it's all about risks, basically. If the evaluator see your project as risky, lack of clarity, the TRL is not high enough, if you lack proof of performance or evidence, all of these could lead to failure of your application. So please spend time on the risks, the mitigations, be precise on TRL, ensure that you have proofs, supporting documents, and that you express yourself very clear and precise throughout the application. So, in the end, how do you prepare yourself for the application writing. I think it's very important that you start as early as possible. So as soon as you plan to send an application to Innovation Fund, you should really ask for help, study the call documents, download all of them, read carefully through the guiding documents and all the criterias. You can also check with CINEA. You can get assistance from third parties, and I think it's very good to prepare yourself, check that you have all the required documents, that you have used all the correct templates, and before you are submitting, you should definitely do a second consistency check and maybe a third consistency check throughout your application. You should have a clear plan how to execute the application process, and ensure that you have enough resources to write the application. It's a lot of work, and you should definitely have anchorage with the top management, so they support the application and ensure that you have enough resources to do this application. If you don't, it's maybe better to hold your application until next year, or ask for more resources. To spend a lot of resources in a poor application which will probably not be granted anyway is just a waste. So if you're serious, if you want to get a project with Innovation Fund, it's better to go all in and do it as good as possible. Okay, some good practice and lessons learned in the end. You will find Innovation Fund, the previous granted Innovation Fund projects. You can find them in the CINEA webpage. You will also find your national contact point here. And you can ask them for guidance and experience. Please also ask some companies and projects that has previously been granted. I know a lot of them are willing to share some good information and good tips on the application writing. There are also companies that can assist you during the process to ensure that the application writing goes smoothly and that you answer all the needed questions. So one example, this is projects in Norway being granted by Innovation Fund already. So there's a lot of companies that has received successful grants, and I've been in contact with some of these companies prior to giving this masterclass lecture. Okay, some final advice maybe. It is really challenging to bring innovations into a large-scale project with high impact. So you should build up the application piece by piece and cover the entire projects and make sure that you also include all the external factors. Scaling up a project or a technology is often more complex than assumed. It's important that you tell the same story throughout the entire application. You need to be consistent, you need to be conservative and credible. Do not promise more than you can deliver. Be very clear on your technology, how it works, what is the business case, and what is the impact of your project. This must be very obvious, very clear for the reviewer. And by this, I wish you very good luck. Hope you want to send an application to Innovation Fund, and I really hope you will succeed. Thank you.